Hello students, myself Milan Patel, Assistant Professor at LJIET Institute of Engineering and Technology. Today's topic is about acoustical construction. So let's begin. The word acoustic is originally derived from a Greek word meaning to hear. Hence, the acoustics is defined as the science of sound, and such it discusses the origin, propagation, and auditory sensation of sound. A sound is produced when part of the atmosphere is compressed suddenly, but due to elasticity of air, the particles originally disturbed in turn disturb the neighboring particles. Ultimately, the compression is propagated or spread away from the source of the sound. The sound thus travels in the form of waves, and when these waves come near our eardrums, we feel a sensation of hearing. That's how we feel the sensation of hearing. Okay, now let's see what are the requirements of good acoustic material in construction of sound insulated structure. Okay, first requirement, material should be durable and should not be liable to be attacked by insects, termites, etc. It should be easily available at reasonable cost. Okay, it should be efficient over a wide range of frequencies. The material should be fire resistant also. It should be non-hygroscopic and heat insulating. Here, hygroscopic means the tending to receive the moisture. Okay, the material should be self-supporting and should be capable of easy fixing. It should give pleasing appearance after fixing also. It should have high coefficient of absorption of sound. Okay, and it should have sufficient structural strength. Okay, so these are the various requirements of good acoustic material, or you can say these are the various points to be considered while selecting a good acoustic material. Okay, now let's see what are the various types of absorbent materials used in this acoustical construction. First is hair felt, second is acoustic plaster, third is acoustical tiles, fourth is strawboard, fifth is pulpboard, next is compressed fiberboard, then compressed wood particle board, perforated plywood, wood wool board, and quilts and mats. So these are the total 10 types of absorbent materials. Okay, let's discuss these all types of materials one by one. Starting with hair felt. This material was used by Professor Sabin in his experimental works. This is how hair felt looks like. The average value of coefficient of absorption of 25 thick hair felt is around zero point 0.6. Okay, so this type of material can be used as the sound insulation material. Okay, second type of material is acoustic plaster. This is also known as the fibrous plaster and it includes granulated insulation material mixed with cement. This is how acoustic plaster looks like. If quantity of cement is more than required, the plaster will not have sufficient pores to become effective for acoustics. Okay? If quantity of cement is less, the plaster will not have enough strength. So we have to decide the quantity of cement while producing or while manufacturing of this acoustical plaster. Okay? Thus, the quantity of cement should be carefully decided. For thickness of 20 and density of 1 kilonewton per meter cube, the acoustic plaster possesses an absorbent coefficient of 0.3 at 500 cycles per second. The acoustic plaster boards are also available in the market. They can be fixed on the wall and their coefficient of absorption varies from 0.15 to 0.30. Okay. The next type of absorbent material is acoustic tiles. This is how acoustic tiles looks like. These are made in factory and sold under different trade names. The absorption of sound is uniform from tile to tile and they can be fixed easily. However, the acoustical tiles are relatively costly than the other absorbent material. They are more suitable for rooms in which small area is available for the acoustical treatment. Okay. The next type of acoustic or absorbent material is strawboard. This is how strawboard looks like. This material can be also used as absorbent material with a thickness of 13 and density of 2.4 kN per meter cube. It possesses a coefficient of absorption of about zero point 0.3 at 500 cycles per second. Okay. Next is pulpboard. This is how pulpboard looks like. These are the soft boards which are prepared from the compressed pulp. They are comparatively cheap and can be fixed by ordinary paneling. The average value of coefficient of absorption is around 0.17. Okay, so this is a very cheap material you can use in the sound insulation. Next is compressed fiberboard. This material may be perforated or unperforated also. The average coefficient of absorption for the former or the normal compressed fiberboard is zero point 0.3 and for the latter it is 0.52. Okay. The next is compressed wood particle board. This is how compressed wood particle board looks like. This material is provided with perforation and it can be painted also like this in this figure. With a thickness of about 13 mm, the average coefficient of absorption of this compressed wood particle board is around 0.4. Okay. Next is perforated plywood. This material can be used by forming composite panels with mineral wool and cement asbestos or with mineral wool and hardboard. It is generally suspended from the trusses. The average value of coefficient of absorption for the former composite panels is as high as 0.95 and for the later composite panel it is about 0.20. Okay, so this is called as perforated plywood sheets. Next is wood wool board. This material is generally used with thickness of 25 mm and has a density of 4 kN per meter cube. The average coefficient of absorption of wood wool board is about 0.2. Okay, this is how wood wool board looks like. Next is quilts and mats. These are prepared from mineral wool or glass wool and are fixed in the form of acoustical blankets. This is how quilts and mats looks like. The absorption coefficient depends mainly on thickness of quilts or mats, density, perforation, mode of fixing, nature of backing, and also the frequency of the sound. Okay, so these are the various materials which can be used in the absorption of the sound. Okay, or you can say in sound insulation. Now, let's see what are the various conditions for good acoustics of an auditorium or a hall. The initial sound should be adequate intensity or loudness. This is quite obvious as it is impossible for a speaker to be heard over a long distance without the help of sound amplification system, right? The sound which is produced should be evenly spread over the whole area covered by the audience. If this condition is not satisfied, the conditions tending the formation of echoes will be established. Okay, the initial sound should be clear and distinct so that there is no possibility of disordered speech in the auditorium or a hall. For hall to be used for music, the initial sound should reach the audience with the same frequency and intensity. Okay, all undesirable sound should be reduced to such an extent that it will not interfere with normal hearing of music or speech. The undesired sound may be originating either from inside or outside the room. Okay? So these are the various conditions for good acoustics of an auditorium or hall. Now let's see what are the factors considered in acoustic design of an auditorium. There are various factors which affects in acoustic design of auditorium like volume, shape, sound absorption, site selection, seats and seating arrangements. Let's discuss these all factors one by one. Starting with the volume of the auditorium. The hall should have enough volume and it should be decided while keeping in view the intensities of sound likely to be developed in the hall. For halls to be used only for music, the volume should be large so that there will be enough space for the music to spread in the hall. On the other hand, the halls of small volumes are useful for weak sounds. Okay, the best guide for deciding the volume of proposed auditorium would be the detailed study of an existing auditorium used for similar purposes. So you can visit the well-built auditorium nearby, and based on that, you can decide the volume of your concerned project. Okay, the recommended volumes of different types of auditoriums are as follows, like this. In cinemas or theaters, The volume should be around 4 meter cube to 5 meter cube per person. Okay, if there are 100 person in cinema or theater, the volume should be 400 meter cube to 500 meter cube in between. Okay, for music halls or concert halls, it should be around 4 meter cube to 5.5 meter cube per person. And in public lecture halls, it should be between 3.5 meter cube to 4.5 meter cube per person. Okay, so these are the various criteria given as your reference to decide the volume of the auditorium or hall. That's all about the first factor, volume. Now let's see the second factor, which considered in acoustic design of an auditorium is shape of an auditorium. This is very important consideration, acoustic design of an auditorium, and it involves geometrical aspects of the hall. The path followed by the reflected sound waves are traced and concentration of sound waves, if any, are noted. The concave walls are not good for acoustic purposes as they tend to concentrate sound waves. The plain wall are much better than these concave types of wall, but the convex wall are excellent and they are used to reduce the possibilities of echoes to the minimum extent compared to plain and concave walls. So it is very much helpful to you construct convex wall in design of the auditorium. Okay, a fan-shaped floor plan gives better performance than the other shape. The side walls should be arranged to have an angle of not more than 100 degrees with the curtain line as shown in figure. Okay, the fan-shaped plan gives favorable reflection of the sound from the sides. For talking pictures, the synchronization of sound with lip movement is the most essential thing in auditorium, theaters, etc. For theaters, a person with normal vision should be able to discern facial expressions of the actors on the stage. To satisfy these conditions, the distance of the farthest seat from the curtain line should generally not exceed 23 meters. Okay, so this criteria should be considered in design of an auditorium or hall. Okay, and fan shaped floor plan is the best type of plan you can use in design of the auditorium. Okay, the next factor is sound absorption. The adequate absorbing surfaces should be provided in the hall to control the reverberation. This is one type of sound effect which is produced in the auditorium. The acoustic design of an auditorium will be incomplete without the provision of such a surface. The careful study of the hall should be made before recommending the type of absorbent material and its location in the hall. The surface from which the sound is likely to be reflected should be so designed as to assess distribution of sound. The areas likely to cause objectionable sound reflection should be clearly sorted out from for the treatment with sound absorbing material. Such areas include rear walls, then balcony parapet, concave surfaces, etc. The rays should be properly distributed on the remaining surfaces. Okay, so that's all about the sound absorption factor. Okay, next is site selection. Noise pollution is the most important consideration in site selection. If the site is not situated in a quiet place, elaborate, costly arrangement will have to be made to have an acoustically good hall. For auditoriums without air conditioning and requiring doors and windows to be kept open during performance, the orientation should be such that the external noise is permitted to the minimum possible extent. Depending upon the surrounding noise level of the site, structure design, orientation, layout, and such other factors, it should be seen that the background noise level not exceeding 40 decibel to 45 decibel is achieved within the hall. So the site of the auditorium should be as quiet as possible. Okay. And the last factor which is considered in acoustic design of an auditorium is seats and seating arrangements. The seats should be arranged in concentric arcs of the circles. The center from which the circles should be drawn should be located as much behind the center of curtain line as the distance of curtain lines from the auditorium rear wall. The factors which affects the seat and sitting arrangements are given here. First is arrangement. Second is back-to-back distance. Then balcony seats, covering of seats, front must row, then raising of seats, width of seats, etc. These are the various factors which affects the seats and sitting arrangements of an auditorium. Let's see these all factors one by one, starting with the arrangement of the seats. The seats should be staggered sideways in relation to those in front so that a listener in any row is not looking directly over the head of the person in front of him. Okay, so this is how you can arrange the seats in the auditorium. Then second is back-to-back distance. The back-to-back distance of chairs in successive rows or seats should be at least 450 mm, and this distance may be increased up to 1000 mm or so for extra comfort point of view. Okay, so minimum back-to-back distance should be around 450 mm. Third is balcony. Where balcony is provided, the precautions to be taken are as follows. The length L1, you can clearly see in this figure, L1 is the length of the balcony, should not be greater than 2 times H1. Here, H1 you can clearly see in this figure also. This is the height of the balcony from the ground floor. Okay, so L1 should not be greater than 2 times H1. L1 should not be greater than L by 3. H2 should not be less than 3 meter and H3 should not be less than 2.3 meter. Here L is equal to length of auditorium, you can clearly see. L1 is equal to projection of the balcony, okay, or you can say cantilever portion of the balcony from the column or the slab, okay. H1 is the height of balcony edge at end and H2 is height of balcony edge at entry, okay. H3 is equal to height of last row in balcony from projection room. Okay, so these are the various points or the factors you can consider while deciding the balcony sizes. Okay, in an auditorium. This figure shows the longitudinal section of a typical auditorium. If the balconies are deep, there are chances for the sound shadows to be developed. It is due to the fact that the seats underneath the balcony do not receive the ceiling reflections. The defect of sound can be rectified by providing angle reflector as shown in this figure. This angle reflector reflects the sound and reduce the sound shadow problem. Okay. The next factor is balcony seats. The elevation of balcony seats should be such that line of sight is not inclined more than 30 degree to the horizontal. Okay. Fifth is covering of seats. If covered or upholstered seats are provided, the acoustic characteristics of the hall are not appreciably altered by the fluctuating audience occupancy. Okay. Next is frontmost row. The angle subtended with the horizontal at the frontmost observer by highest object to seen on the stage should not exceed 30 degree. So this angle should not be more than 30 degree. Okay. On this basis, the distance of the first row works out to about 4.5 meter for cinemas and 3.6 meter for theaters. Okay. So you can consider this type of figures while deciding the frontmost rows. Next is raising of seats. The successive rows of seats should be raised over the preceding ones for good visibility and good listening conditions. The rise in level may be between 80 mm to 120 mm per row. As a thumb rule, the angle of elevation of the inclined floor of that auditorium should not be less than 8 degree. Okay, it should be more than 8 degree. And the last factor is the width of seats. The width of seats should be between 450 mm to 600 mm as per comfort point of view. Okay, so that's all about the factors which considered in acoustic design of an auditorium. Okay, now let's see what are the objects involved in design of an auditorium. There should be good direct path for the sound. This will enable the sound to be heard loudly and clearly and will avoid confusion with subsequent reflections. It should be seen that none of the subsequent reflection has the same strength as the original sound. And the third is the desired degree of reverberation should be provided in the auditorium. Okay, so to achieve these three objects, we have to design an auditorium. Okay, now let's see what are the various defects in an auditorium and what are the various remedies to reduce these type of defects. Okay, first is reverberation, then formation of echoes, sound foci, dead spots, loudness, and exterior noise. Let's discuss first reverberation. The defect of excessive reverberation is very common in many auditoriums. The effect is that the sound once created prolongs for a longer duration, resulting in confusion with the sound created next. Okay, this is called as reverberation effect. The remedy to reduce this type of effect is to correct the time of reverberation by suitably installing absorbent materials. Okay, if you install the various absorbent materials surrounding the hall, you can reduce this reverberation problem. That's all about the first defect, reverberation. Now let's see the second defect, which is formation of echoes. When the reflected surfaces are situated at a distance greater than 17 meters or so, and when the shape of the auditorium is unsuitable, the formation of echoes takes place. How you can reduce this type of formation of echoes? By selecting proper shape of an auditorium like FanShape shape, okay, FanShape, or by providing rough and porous interior surfaces to disperse the energy of echoes. Okay, so by providing this type of rough or porous interior surfaces, you can easily reduce the formation of echoes. Now let's see the third defect, which is sound foci. In case of concave reflecting interior surfaces, certain spots are formed where reflected sound waves meet and create a sound of large intensity. These spots are known as sound foci. The remedy to reduce this sound foci defect is done by avoiding curvilinear interiors. Okay, you have to provide convex type of interior surfaces compared to concave type of reflecting surfaces. Okay, and the second remedy is by providing highly absorbent materials on the focusing areas where this type of problem can be generated. Okay, so these are the two remedies to reduce this sound foci defect. The next defect is dead spots. This is exactly reverse to the defect of sound foci. Because of high concentration of reflective sound at the sound foci, there is deficiency of reflective sound at some other points also. These points where there is a deficiency of reflective sound is known as dead spots. The sound level at dead spots is generally inadequate for satisfactory hearing. Okay, the remedy to reduce this dead spots is done by the installation of suitable diffusers which diffuse this type of you can say high intensity sound formation and reduce the possibilities of the points where sound foci problem is observed, and because of that the number of dead spots are also reduced. Okay, the next effect is loudness. This defect is due to lack of reflecting surfaces near the source of sound and excessive absorption of sound in the hall. The remedy to reduce this problem is done by arranging hard reflecting surfaces near the source of sound and in adjusting the absorption of the hall so as to give an optimum time of reverberation. If length of the hall is more, it is desirable to provide more than one source of sound by installation of loudspeakers. Okay, or by carefully adjusting the location of loudspeaker, you can reduce this type of defect. Okay, and the last defect in auditorium is exterior noise. This defect is due to poor sound insulation and hence the exterior noise enters the auditorium either through loose doors and windows or through walls and other structural elements having improper sound insulation. The exterior noise is developed by vehicles, factories, cooling plants, etc. Remedy to reduce this exterior noise is done by providing suitable sound insulation to various components of the auditorium. If you provide proper sound insulation in number of walls, in number of doors and windows, this problem of exterior noise can be easily rectified. So that's all about the defects in an auditorium and how can you reduce this type of defects in an auditorium. That's all about today's lecture. Thank you for watching.